Hi everyone. Welcome to my short story assignment presentation. Today, I'm going to walk you through a fascinating and rapidly evolving area of technology, which is generative AI. More specifically, I'll be summarizing key insights from recent survey papers, including the one I selected. So, the goal of this presentation is to simplify complex research and translate it into a clear, practical understanding of how modern AI systems are built, how they reason, how they use tools, and how the overall ecosystem is changing as we move into 2026. Let's begin our journey. Uh, First, we have this slide, which is basically saying what is generative AI. So, to start with, let's define what generative AI is. So, generative AI refers to a class of models capable of creating new content, whether that's text, images, audio, video, or even scientific hypothesis and code. So, since 2022, models like GPT 3.5, GPT 4, Llama, Mistral, Claude, and many others have transformed the landscape. They have enabled things like content generation, reasoning, tutoring, automation, intelligent search, and agent based applications. So on this slide, you will notice three key points highlighted. First one being survey importance. So surveys play a big role in this field because AI changes so quickly. So researchers depend on surveys to track advancements and understand the bigger picture. Second one is key developments. We have seen large language models become more accessible, more capable, and more multimodal. Developers now have tools to build AI powered applications faster than ever. Now, the third one is AI systems and capabilities. So, generative models aren't just outputting random content, they demonstrate increasingly human like reasoning, creativity, and technical capabilities. So, this sets the stage. The next step is understanding the structure, the taxonomy of Gen AI ecosystem. So, that brings on to the next slide, which is seven pillars of generative AI. So, this slide is one of the most important in this entire presentation. Here, the survey outlines seven core pillars that define modern generative AI systems. Let me walk you through each pillar. First one is foundation models. Now, these are the large scale models like GPT, Llama, Mistral, and DeepSeek. They serve as the core intelligent layer. Then we have prompting techniques. This includes everything from basic prompts to advanced reasoning frameworks like then chain of thoughts, then tree of thoughts, React, and more. Then we have agents. So LLMs evolve beyond simple chat completion into systems that can plan, reason, execute actions, and use tools. Then we have memory systems. This involves long-term memory, short-term memory, and knowledge retrieval systems like RAG. Then we have tool use pipeline. So tool use pipeline. So model LLMs can call APIs, run code, access databases, and perform tasks beyond text generation. Then we have evaluation benchmarks like MMLU, GPQA, Agent Bench, and Arena Hard help measure model reasoning and tool use. And lastly, we have safety and risk. This includes hallucination, prompt injection, autonomy risks, governance, and more. So these seven pillars represent the entire cycle of generative AI from model design to development. Now, starting with uh, starting with foundation models. So these models form the backbone of the entire ecosystem. The 2025 trend shows a shift from the bigger is better mindset. Instead, we see a smaller, more efficient models outperforming older giant models. Techniques like mixture of experts, speculative decoding, quantization, and distillation making models faster and cheaper. On device models become powerful enough for real workflows. So the foundation of Gen AI is becoming more efficient, more flexible, and more engineered. Then we have advanced prompting techniques. So in that we have chain of thought reasoning. So models explain their steps one by one. This is great for math, logical puzzles, and step-by-step tasks. Then we have tree of thought. So instead of one linear path, the model explores multiple branches. This improves complex decision making. Then we have React. This is not the React JS, which most of people knows. This is reason plus act. So this combines internal reasoning with external actions. The model might think, uh, then decide to call a tool, search the web and run code. Then we have graph of thought. This technique forms interconnected reasoning paths similar to a knowledge graph. It's extremely powerful for research tasks or long horizon planning. So this prompting innovations consistently outperform traditional methods. Today's models don't just follow instructions, they think, branch, explore, and evaluate their own reasoning. Then we have architectures. So this slide is all about AI agents. An agent is not just a chatbot, it's a system that can plan, reason, call tools, store memory, execute tasks, verify results, and improve itself. Then agent core components. So we have five different uh, components which are core components of agent. We have planner, which determines steps needed to solve a task. Then we have reasoner, uses chain of thought, tree of thought, graph of thought to think logically. Then we have tool caller. It interacts with APIs, code documents, and databases. At, and we have memory, which stores context, knowledge, or task history. And at last, we have executor. So it performs the actions and evaluates outcomes. Then multi-agent systems. So one agent could be a planner, another could be a researcher, another could be a tool specialist, and another could be a safety checker. They debate, refine ideas, and supervise each other, mimicking human team structures. Deployment considerations. So we see key deployment concerns, which is infrastructure requirements, large-scale scalability, integration with existing enterprise systems. This area is becoming known as LLM ops, similar to DevOps, but specialized for AI pipelines. So overall, agent architectures are the next major direction of generative AI, moving from passive models to active autonomous systems. Then we have memory systems and RAG. Now, agents require memory, right? And otherwise, they forget everything outside a single prompt. So, memory techniques include episodic memory, semantic memory, procedural memory, knowledge graphs, graph RAG, agent RAG. Memory allows agents to perform long horizon tasks like research analysis and workflow automation. It also makes LLMs more reliable and less hallucination prone. And then evaluation, safety, and challenges. So survey paper emphasizes that better AI requires better evaluation. So evaluation dimensions are reasoning benchmarks, tool use benchmarks, long context benchmarks, safety and alignment tests, hallucination metrics. Major challenges are hallucination persist multi-agent systems can compound errors, on-device constraints limit model size, safety risk like prompt injection and data leakage, cheapened model outputs can reduce reliability. So these challenges are active research areas right now. Then we can move on to future direction. So what's next for generative AI? Now, survey papers predict smarter, smaller, more efficient models, hybrid reasoning models, large-scale multi-agent environments, stronger safety frameworks, on-device and edge AI that becomes more like an operating system than a chatbot. We are entering an era where AI is not just a model, it's a complex stack of reasoning, memory, tools, and collaboration. So, thank you so much for watching this presentation. This video summarized the evolving stack of generative AI from models to prompting, agents, memory evaluation, and future directions. Thanks again. Bye bye.